Blockchain is a promising breakthrough technology that is highly applicable in manifold sectors such as supply chain, different industries from aviation industry to healthcare and education, financial sector, and cryptocurrencies. According to the main characteristics of blockchain technology including traceability, transparency, smart contracts as well as security, this technology not only is used for its main application as a cryptocurrency, but also is applicable in manifold areas such as government elections, healthcare and logistics. All the transactions that have occurred in the network are recorded by the blockchain through applying a distributed database and the collaborated nodes among them. The blocks are performed by these nodes which are known as miners. Thus, the problems happening due to the trust of a centralized party can be addressed successfully using this system, and this technology can bring security to the transactions as employs a distributed way that is not related to any trusted party. These features bring other qualities such as decentralization, trust, and immutability to blockchain technology. The adoption of blockchain technology is accompanied by a range of issues and challenges that make its implementation complicated. To facilitate the successful implementation of blockchain technology, several blockchain adoption frameworks have been developed. However, selecting the appropriate framework based on the conformity of its features with the business sector may be challenging for decision makers. We are going to introduce the adoption frameworks that are most commonly used to assess blockchain adoption and realize business sectors that these models have been applied. After developing and introducing new technologies, it is important to consider the adoption rate of the platform utilizing the user's acceptance to gain more development. The acceptance rate helps decision makers in the development step to consider the problems that users may face through applying technology. This factor is illustrated as an important antagonism to the term refusal, which also means the decision to apply a technology/innovation positively. Different frameworks have been developed to illustrate the user's adoption, like theory of reason action, theory of planned behavior, technology acceptance model, diffusion of innovation, unified theory of acceptance and use of technology, e-service technology acceptance model, task technology fit model, technology organization environment. Herein, we would like to introduce some of them. Theory of reason action is utilized to study the behavior of the people when they use IT. Three main components that are used in this model are as the following. Attitudes, which include favorableness of the feelings of individuals for an attitude, social norms, which are about people's social influence, intentions, including whether individuals decide to perform a behavior or this factor is influenced by the former ones. Derived from the theory of reason action framework, technology acceptance model was to address the uncertain status of psychometric and theoretical and theory of reason action through eliminating subjective norms. The technology acceptance model framework is one of the most widely cited adoption frameworks and includes the perceived ease of use and perceived usefulness as the main factors. Although the impact of attitude toward technology use is another vital factor in applying the technology acceptance model framework, not only does technology acceptance model contain business intelligence, but the impact of two vital beliefs is also considered on the user's attitudes, which are examined as the favorableness and unfavorableness toward the system. In this model, the influence of perceived ease of use and perceived usefulness on the attitude and business intelligence are direct and indirect, respectively, and the perceived ease of use impacts the perceived usefulness directly. Technology organization environment was initially described in the processes of technological innovation by Tornatsky and Fleischer. This is about the whole innovation process ranging from the development by the entrepreneurs or engineers to its adoption by users. Technology organization environment, however, includes one section of this process about the impact of the firm context on the innovation implementation and its acceptance. This framework considers three main contexts to explain how the elements of a firm impact the adoption decisions at an organizational level. The behavior of the individuals can be considered as systematic and volitional. In addition to these components, for testing and evaluating the theory of reason action model, three boundary factors are defined, including the stability of intention over time, volitional control, and the intention measurement considering context, target, time, specificity, and auction terms. Blockchain, as a promising breakthrough technology, possesses diverse applications in a wide range of areas such as industries, banking, healthcare, etc. The special features of this technology make it essential to adopt for companies. However, possible risks and challenges during the implementation of the technology can overshadow the success of the process as well. That is the reason why studies on the adoption and satisfaction of the users are vital to determine the significant elements affecting the implementation of the blockchain and also address the issues that can address acceptance challenges. Blockchain adoption in different industries such as aviation, logistics, healthcare, education, banking and financial sector has been widely studied. Extended Technology Acceptance Model was utilized for studying the blockchain adoption in the aviation industry in Korea. For this purpose, Li Shui used 3 sub-factors for each of the main categories of the Standard Technology Acceptance Model. They listed the factors with a positive impact on the blockchain adoption as digitized management, tracking and tracing, the management of air traffic, industry standards and regulatory governance, optimization on efficiency and technological improvements. The technology, organization, environment-based framework was used in the studies on blockchain adoption in industries as well. They listed the factors with a positive impact on the blockchain adoption as digitized management, tracking and tracing. They used different subcategories for 3 main constructs including organizational, technological, and environmental. However, between those factors, they identified government support and policy, infrastructural facilities, and the availability of specific blockchain tools as the most significant ones. In another different concept, Fernando team focused on examining the drivers of blockchain adoption together with carbon performance. They chose a technology, organization, environment model, and identified technical competency and lack of competitive pressure as the important adoption factors. The other areas that researchers focused on in their works were the studies on the blockchain application in education and healthcare industries to obtain the significant variables in the adoption of this technology. Balasubramanian used a readiness assessment framework to study barcode acceptance in healthcare. In this study, individual stakeholder readiness, stakeholder collaboration readiness, and facilitating conditions readiness were considered as the main categories, which also include different variables as the subcategories. They identified trust, infrastructure, privacy, innovation propensity, and regulatory/legal aspects as the key conditions required for widespread blockchain adoption and also highlighted the vital role of governments. The higher education sector was the subject of work by Kumar. They, however, applied an extended technology acceptance model framework in the study. They used perceived security or privacy and trust as the additional variables. The result of this study identified the positive effect of incorporated factors on the adoption intention of the individuals. In addition, the perceived security and privacy factor were found as important factors impacting trust, ease of use, and perceived usefulness. Using new frameworks with several factors as the barriers and challenges of the adoption and integrated frameworks were the approaches of some other studies in the industry field. For example, Su Yongshun used 11 barriers in their model to study adoption in the architecture, engineering, and construction industry. Barriers were selected as the variables such as scalability issues, lack of interoperability and standardization, lack of knowledge and expertise, project complexity, and industry resistance to change. Pushi focused on a novel conceptual framework based on the technology acceptance model and technology, organization, environment model, and also added new features in maritime industries. They used 5 main dimensions including technical features of blockchain, commercial benefits of blockchain to the industry, applicable areas in the maritime domain, major maritime stakeholders involved, and the potential adoption challenges in the industry. They found all technical aspects as the significant basis of the commercial benefits gained by the industry. We can find, nowadays, many researchers have employed extended technology acceptance model or technology, organization, environment frameworks by adding new variables or a combination of different frameworks instead of the single and traditional models. New conceptual or theoretical frameworks were also the main focus area of many researchers. It is shown that the adoption of blockchain is studied in different fields, although there are some sectors and main applications which are not considered in the adoption studies. So, based on the results achieved, the aim of the future study will be utilizing the results of this work to gain a new comprehensive framework which is applicable to investigate blockchain adoption in manifold fields. The model also will be tested and the results will be analyzed to obtain the most significant factor.